Okay, let's talk a little bit about changes in matter. So when we talk about changes in matter, you kind of cluster it into a few different types of changes. We can have physical changes in matter, and that means that there's some observed physical change, but the chemical composition is the same. So what you actually have, the components that make it up are all still the same. Everything's bonded together the same, but physically something's changing, okay? And so when we talk about physical changes, usually what we would be talking about is transitions between physical states, okay? It's the most basic type of physical change that we have. And so if you transition between a solid phase of a substance and the liquid phase, it's still the same substance, okay? But physically, it has different characteristics, okay? And so that is a physical change, okay? And so solidifying or freezing something versus melting something, you're going to change physically what it is behaving like, but it's still made up of the same atoms or the same molecules that it was before those transitions, okay? Or we can transition between a liquid and a gas phase for a substance. So we can evaporate it or we can condense it. It's still going to be made up of the same particles, but it just has different characteristics. And you can even transition things between solid and gas phase depending on the substance. And that is just a physical change. So all of those things are only changing the physical state or the physical characteristics then of that substance. And those particular types of physical changes involve heat being absorbed or released, okay? And you can even quantify that. We're not going to talk about that right now. We're not going to focus on the terminology associated with those, which are kind of on that diagram. Just the basic idea that a physical change is changing some physical properties of this substance, but not changing what substance we actually have. Okay, so that's the most basic type of change that a substance can undergo. Whereas you can also have chemical changes, okay, and so that's when we actually convert one substance to another, or convert more than one substance to more than one new substance, okay? So it can be very simple, it can be very complicated. And a lot of times, instead of saying something's a chemical change, we'll usually refer to it as a chemical reaction, okay? And so in this conversion of substances from one thing to another, it's going to involve some sort of breaking and or forming of chemical bonds, okay? So breaking things apart and reattaching them in a different way, okay? So we're not talking about nuclear changes, okay? Although you can also have nuclear changes, which is kind of like a chemical reaction, but it involves the nucleus. That's a little more specialized kind of chemistry. We're not going to go into that at the moment. So we'll stick to physical changes, and chemical changes are kind of the most basic changes that our matter can undergo. Okay, now right along with those changes, we have energy changes. So the energy changes are typically associated with one or the other or both of these, okay? So when something undergoes a physical change, very often right alongside with that, there's an energy change. So specifically, if you are talking about phase transitions, going from a solid to a liquid or a liquid to a gas or whatever, there's always some heat going in or out, and that heat is some sort of energy going in or out of that system, okay? Same with chemical changes or chemical reactions. Very often a chemical reaction involves some change in energy. And so there's going to be some energy either absorbed by that or released by it when that chemical reaction occurs. So usually these energy changes all occur right along with some sort of physical or chemical type of change. Although I guess you could potentially add some energy to something and not do a physical or chemical change. It's just pretty rare. Those are usually tied together. Okay, now let's talk a little bit more about energy. So energy is simply the capacity to do work or transfer heat. Okay, now to do work really means it generally we would associate work with some sort of mechanical thing. So it does something for you. That is a little more complicated, usually in basic, if you're just talking about the basics of chemistry, you may not really go into work so much. But the transferring heat part is really important. That you really can't get away from talking about, okay? And so that's really the main focus, at least in general, starting out in chemistry. Now, with energy, we can talk about different types of energy. There's two kind of major categories of energy that we split things into. You can have potential energy, that's basically the energy of position, usually is how it's defined. And so it's associated with the position of things relative to other things, whether it is relative to the Earth, or in chemistry, usually we would look at it on more of a level of chemical energy. So how one atom is in position with another atom, the electrons within that atom are in position with its nucleus. And so that's all related to a potential energy of that substance. And then you also can have kinetic type of energy. So that's energy associated with motion, okay? And so an object actually moving. Now, on the chemistry level of things, usually we would focus on that being thermal energy. And so actually measuring temperatures. And that temperature measurement is associated with the kinetic energy of the particles that make up whatever that sample is. Okay, so instead of looking at them on kind of the big, I don't know if I should say big scale, but the more general classification of potential and kinetic energy, usually when we talk about energy, we're focused on either chemical energy, so based on the actual makeup of that substance, or the thermal energy, so the temperature or changes in temperature of that. Now, when we talk about energy, a lot of times we associate that with some sort of process, so some physical or chemical change. And when we do that, we'll want to focus sometimes on the direction of that energy flow. So is the energy coming into our substance, or is the energy leaving our substance? Okay, and so there's a couple sets of terms you could use. We could talk about it being endergonic or exergonic, and that's just in general talking about energy going in or out of something. Okay, so if the energy is absorbed, it's endergonic. If it's released, then it's exergonic. Okay, now most of the time, the energy that we're talking about is heat. So heat is either leaving or coming. Okay, and so either something is being heated up or something is cooling down. Okay, and we'll use the terms endothermic and exothermic to indicate that. So if something is endothermic, then it is absorbing heat, okay, meaning its temperature is going to be going up, okay? Whereas if something is exothermic, then it is releasing heat, and if it's releasing heat, it's actually going to be cooling down. Okay, now, last thing I want to talk about with energy is spontaneity, okay? So different processes that occur, so different changes, physical changes and chemical changes, Those things, like I said, are typically associated with some sort of energy change. But those changes may be things that are spontaneous or non-spontaneous, okay? So they can be kind of one or the other. And so if it's spontaneous, it's something that happens on its own, okay? So naturally, it just undergoes that change. As long as that stuff is there, if it's some sort of chemical change, then as long as the substances that need to react with one another are there, they will react spontaneously. Okay? Whereas if something is classified as a non-spontaneous change, then that is something that we have to put energy into to get it to transition. Okay? And so that terminology tells you something about the energy. Okay, so if something is spontaneous, then it's something that happens on its own. And so typically that's something that is going to then release energy. Okay, whereas a non-spontaneous process definitely is something you have to put energy into. Okay, I guess a spontaneous process could happen with no energy change at all. But in general, we would associate that with it releasing some sort of energy. Okay, that's why it's spontaneous, because it naturally wants to lower its energy. Okay, so that's it for talking about changes.